Hi, this instructional video and the following assignment is about factoring, simplifying quadratic expressions by factoring. So here's a couple of expressions. And to factor, for example, number 1. Well, first of all, this is a trinomial. It's a polynomial that has 3 separate terms. 3 terms. And each one of these, if you noticed, there's something in common. There is a factor that is shared by these 3 terms. If you said 3, that would be correct. Each one of those has a factor of 3 in it. So what you can do is factor out that factor, saying that word a little too many times, 3. And you could see what will remain. What that means is factoring is the backwards or inverse operation of distributive property. So this is what I would ask. Well, 3 times what will give you 3x squared? Yeah, that would be x squared. 3 times x squared is 3x squared. Now 3 times what will give you positive 6x? Positive 2x, of course, because 3 times 2x is 6x. And the last one is sort of a dead giveaway. 3 times what gives you negative 9? So if you said minus 3 or negative 3, that would be correct. But now we have a trinomial that can also be factored. Well, what do you mean? I mean this. That 3 has been factored out, so we're going to leave it like that. This is a product of 2 binomials. This is where I ask the students, hey, what times what will give you x squared? Then you'll say, well, x times x will give me x squared. That's right. This is called the AC factor. What times what could possibly give you a 3? Then you'll say 1 and 3. That's right. 1 times 3 is 3. But what must these 1 and 3, what must their signs be so that if you multiply them, it will give you a minus 3 or negative 3? And if you were to add those integers or combine them, it will give you a positive 2. Then you will realize the bigger integers better be positive. So that 3 minus 1 will give you 2. And if you multiply them, 3 times negative 1 is negative 3. And there you have it. This is the complete factor form of this polynomial. Now try this one. This one's actually easier. So easy, you spell it with 2 letters, E-Z. Try it. Good. So this time it's not a trinomial, a polynomial with 3 terms. This is a binomial. It's a polynomial with 2 terms. And it gets a little weird. What is the common factor between 20 and the 45, between those 2 coefficients? What number goes into 20 and 45? Well, the only possible number is 5. So you're going to factor out the 5, like the way we factored out the 3 between those 3 terms. But something else. What do these variables, what do they also have in common? They both have at least 1 x's. This one has 2 of them. This one has 1. So we're going to factor out that variable. And they also seem to have at least 1 y's, or 1 y. So you're going to factor out a y from each of them as well. And we're going to see what remains. So we're going to go backwards of a distributive property, which means 5xy times what would give you 20x squared y. So if you said, hey, 5 times 4 is 20, x times x will give you x squared, and there you don't want to multiply anything else but an invisible 1 to a y, which will give you a y. That's it. And that will be correct. Then 5xy times what can possibly give you negative 45xy squared? Well, you know it's going to be 5 times 9 is 45. And x times, well, you don't want to multiply anything to an x besides a 1. So y times y is y squared. And that's it. And unlike last time where we had a trinomial where we could still do AC factor. Here we have a binomial with nothing in common, so that's where you stop. This is the completed factor form that made up this polynomial with two terms. There you go. So if you got that, I need you to go to Quick.Math Shop website and do the following page 51 from the blue manual. Numbers 1 through 8. All whoop-de-doo. Big homework. All right? Good luck.